Welcome back, Math 2. Today we're going to continue talking about similar figures, and we're going to start using proportions to be able to find missing pieces of shapes or be able to use this in real life to find missing pieces that we need. Okay? So, quick refresher, the word similar means that we have proportional sides or proportional size, but same shape. Okay. So one of the things you'll start seeing us use is a ratio. So a ratio is where you compare one unit to another unit and they use a colon in there. So for example, if you were to look at a map or like an architectural drawing of a building, they might tell you, oh, you know what, every 1.5 inches on this diagram means, I don't know, 10 feet, something like that. And it'll be written like this, but you could also use it as a fraction like that, which we're going to have to do tomorrow on our homework. So let's talk about where these fractions come in. And they come in a proportion. All right, now, if you've taken chemistry, you would have used proportions a lot when you were converting units. This is similar, but it's a little bit on a smaller scale. So a proportion is comparing two fractions or scale factors. Okay. So you could call them fractions, scale factors, or ratios, because a ratio is also a fraction and a proportion, and they're all the same thing, just written in different ways. Okay? So when we write these fractions, we are comparing matching stuff. So I'm basically comparing things that match. Okay. So when we write a proportion, we need to have two-way matching, if that makes sense. It'll make more sense when we get to an example. But let me kind of describe it this way. Okay, so two-way matching. So if I put some number here, okay, the number underneath it either needs to be the matching side or it needs to match what shape it's from. Okay, so I need to have matching this way vertically. I also need to have matching going this way. I can't just put numbers wherever I want them. Okay, so let's do a quick example. Okay. Let's say this was my proportion I was trying to set up because I'm trying to find, oh, what's this missing side here? Okay, so I could write my proportion one of two ways. Okay, I could set up a fraction where I have 3 and 1 be a fraction together because they are matching sides. Okay, like they would, if these were the same shape, it'd be like, oh yeah, 3 matches with 1. I could also have a fraction between 3 and 5 here because they are part of the same shape. So I could write this as 3 over 1 equals 5 over x. So I have matching shape, matching side. Or I could write it 3 over 5 equals 1 over x. So this way I have matching shape, matching sides. There's a lot of different ways to write these. So I just want you to make sure as long as you've matched stuff up, it doesn't really matter if yours looks exactly like your neighbor's. Okay? Let's try a couple practice problems. Okay. We're going to do 1 and 2 together. Okay. So the directions to say for each pair of similar figures, so they do tell us that they are similar. That's useful to know. That means there is a scale factor between them. Write a proportion containing the unknown length, then solve. Okay, so I have a large triangle here in number 1, and then I have a smaller triangle. So I'm going to set up a proportion. So when we do that, we always want to start with 2 fraction bars and an equal sign in between. And then you kind of have to decide how you want to do your matching. I typically do 1 fraction is matching sides, and then across the equal sign is the same shape. But I think maybe for starting, it might make more sense if I start with like, okay, this fraction will represent the large shape, and this one will represent the small. Okay. So let's look at our actual problem now and see what side are we missing? What side don't we know? So on the large shape, I have 15, 18. Oh, and then I'm missing a side here. Okay. On my small triangle, though, I have all 3 sides. Okay. So I know somewhere I need to have an X, and it's on my large triangle, so I might just put it here. You could also put it in the denominator. Okay. Now the X, I need the side that matches with it on the other triangle, which is going to be 6. Okay, those two are matching together. So I need to make sure, since I put X on top, 6 also goes on top. Now for the bottom, I just need 2 other matching sides. So I could either do 15 and 10, or I could do 18 and 12. It's kind of up to you. Some people might say, well, 15 and 10 are smaller. I'm going to go with that. Others might say 18 and 12 are both even. They're divisible by 6, so maybe I should use that because I have a 6. It really doesn't matter. I might just use 15 and 10. If you want to use 18 and 12, you will get the same answer. Okay. So we have our proportion, and now we are going to cross multiply and solve. Okay, so what that means is I'm going to take X times 10 and set it equal to whatever 15 times 6 is. So X times 10 will be 10X equals 15 times 6, I believe is 90. And I'm going to solve for X by dividing by 10. And I get that X, or my missing side, is 9. And just for the heck of it, I'm going to check if that makes sense over here. It does. It's still bigger than the small triangle, which makes sense. Okay, so that is my missing side. Let's try it again. Okay. Number 2, the following trapezoids are similar. Show your proportion and work. Find the length of side Y. So I have this missing side here, side Y. I'm going to set up my proportion. And I think, again, I'll do 1 fraction for the larger trapezoid and 1 for the small. If you wanted to, you could have 1 fraction for each set of matching sides, though, too. Okay? So my missing side is on the small triangle, so I'm going to make sure I put a Y up here. And that Y matches with 5.2 centimeters over here. So that has to be on the top of the large fraction. Okay. On the bottom, I need my other set of matching sides, which are 2.5 and 6.5, and I just got to make sure they're in the right fraction. And now I'm going to cross multiply. Okay. So on one side, I'll have 6.5 times Y. And on the other side, I'll have 5.2 times 2.5, which is 13. I'm going to solve for Y by dividing by 6.5. Okay, and before I actually solve this, let's think about what do you think it should be. So if I look at my larger triangle, my 2 sides are 6.5 and 5.2. So I should have a number that's smaller than 2.5. Okay, so if I take 13 and divide it by 6.5, I get 2, which makes sense. And they did give me a unit on this one, so I want to make sure I include that it's centimeters. All right. I want you guys to try number 3 on your own, and then we will go over it tomorrow in class.